For decades, the image of the Third Reich was associated with destruction, barbarism, and genocide. But beneath that dark shadow, the laboratories and factories of the Nazi regime hid technological advancements that, when discovered by the Allies at the end of the war, generated both astonishment and fear. From revolutionary weapons to unprecedented experiments, what they found was the anticipation of a new era. The war of the future had already begun, and the Nazis had imagined it first. The gas chambers. When Soviet soldiers crossed the gates of Auschwitz on January 27, 1945, they not only found smoking ruins and skeletal bodies, but they also stumbled upon the material evidence of an extermination machine that surpassed any known category of crime up to that point. Among the partially destroyed crematoriums, the sealed gas chambers, the empty cans of Zyklon B, and the charred skeletons of their victims, the industrial core of the Nazi genocide was revealed. Amid the horror, it was the gas chambers that symbolized most clearly the transformation of murder into state policy, into factory routine, into the mathematics of death. The testimony of the survivors from the Sonderkommando, the Jewish prisoners forced to collaborate in the killings, was crucial to understanding the technical and emotional workings of the gas chambers. Many of these men, knowing that their fate was to be killed after a few months of service, managed to leave traces of what they had lived through. Written testimonies buried, stories told to other prisoners, confessions during later trials. In their descriptions, the murder was not an execution but a production line. The prisoners were deceived into entering a hermetically sealed space with fake showers and wooden benches. They were asked to leave their clothes neatly and remember their hook number. Once the doors were sealed, Zyklon B capsules, a cyanide-based pesticide, were introduced through openings in the ceiling or side holes. Upon contact with the air, it vaporized and asphyxiated the victims within minutes. Some testimonies speak of desperate screams, of nails tearing at the walls, of mothers covering their children with their bodies. Others, even more devastating, highlight the silence that took over the room once the gas took effect. Death, after the spasms and agony, was as absolute as the silence that followed. When the gas dissipated and the doors were opened, members of the Sonderkommando entered to collect the bodies. Their work was quick, impersonal, necessary to keep the machine running. Hair was cut, gold teeth were removed, and bodies were sorted by size to facilitate combustion. The chambers were not to be empty for more than a few minutes. The next line was already waiting outside. The Germans had perfected the architecture of murder. The gas chambers of Auschwitz-Birkenau were underground, with facilities that allowed the orderly flow of victims from the arrival of the train to the ovens. The disinfection rooms were arranged as grey zones that dampened suspicion. Music, soothing voices, even nurses dressed in white coats were used. Everything was designed to avoid mass panic, which would have made the process more difficult. In post-war trials, some of the technicians, doctors, and officers involved tried to explain their participation as mere executors of orders. Others, like Rudolf Höss, commander of Auschwitz, offered detailed confessions. Höss described precisely how many people could fit into a gas chamber, how long it took for Zyklon B to kill, and how many bodies could be cremated in a day. His words, cold, technical, devoid of emotion, revealed a mind adapted to crime as if it were a job in administration. For the Allies who discovered the camps, the gas chambers represented the limit of what was imaginable. The first reactions ranged from disbelief to terror. Some British and American officers, accustomed to the horrors of the front, were incredulous at the survivors' accounts. Only when they entered facilities like Dachau or Mauthausen and saw ovens, human remains, documents, photographs, and mountains of shoes or hair did they understand the magnitude of what had happened. The gas chambers, which had long been considered a rumor or a propagandistic exaggeration, materialized before their eyes. The Allied documentation teams began filming, photographing, and recording every corner. In Nuremberg, this evidence would be irrefutable. An important part of the public revelation came from forensic doctors and toxicology experts who analyzed the Zyklon B residues, the structural characteristics of the chambers, the ventilation systems, the mechanisms for opening doors from the outside, and the layout of the facilities. These analyses confirmed that they were not showers or storage rooms, but devices designed to kill efficiently. The gas chambers also left a mark on the collective imagination. Unlike shooting or hanging, recognizable forms of execution, the use of industrialized gas in sealed chambers with no visible executioners seemed impersonal and modern. It was a death without a face, without bullets, without visible blood. Death as a chemical effect. In this sense, the horror was not only moral, but also technical. It showed how science, engineering, and logistics could be used to serve evil with terrifying efficiency. In the decades that followed, deniers attempted to disprove the existence of the gas chambers by citing technical inconsistencies or contradictions in testimonies. However, the amount and solidity of the documentation, the Nazi records found, the confessions of the perpetrators themselves, and the cross-testimonies of survivors dismantled these attempts decisively. The gas chambers existed. They operated daily. They killed hundreds of thousands of people, mostly Jews, but also Roma, homosexuals, Soviet prisoners, and political opponents. The V2, the vertical roar that changed the world. The appearance of the V2 missile in the skies of Europe marked a before and after in the history of war. It was a revelation that shook the foundations of what had until then been understood as conventional armed conflict. For the Allies, this projectile, which fell without warning, without a buzz, without an alarm, with no possibility of defense, represented a threat as real as it was symbolic. The future of war had arrived, and it had come from the heart of Nazi Germany. The V2, or Vergeltungswaffe 2, was the result of years of research led by the young and ambitious engineer Werner von Braun, who, along with his team at the secret Peenemünde base, designed a weapon never seen before, an autonomous projectile capable of leaving the Earth's atmosphere and returning to it on a ballistic trajectory to destroy a target hundreds of kilometers away. Its technical capacity was so advanced for its time that it seemed like science fiction. The missile was 14 meters long, weighed nearly 12 tons, and carried 1 ton of explosives at a speed exceeding 5,000 kilometers per hour, reaching altitudes of more than 80 kilometers. There was no defense against it. It was the first ballistic missile in the world. Its appearance shocked the Allied High Command, which had already suffered attacks from the flying bombs V1, but now faced a completely different type of threat. There was no way to intercept it, neither with anti-aircraft artillery nor with fighters. The V2 did not buzz. It simply fell. The impact occurred first, followed by the sonic boom. The logic of air combat had been broken. The British began to notice the first impacts in September of 1944. Huge craters, devastating shockwaves, and no indication of how or from where the attack had originated. At first, British authorities tried to conceal it, attributing the damage to gas explosions to avoid civil panic. But it was evident that something new had come into play. Winston Churchill, informed before the reports of MI6 and the photographic observations of R.V. Jones's scientific team, knew that the Nazis were developing a technology with terrifying potential. Operation Hydra, launched in August of 1943 by the RAF against Peenemünde, attempted to destroy the development infrastructure but failed to stop the project. Production was dispersed to underground facilities like Mittelwerk, protected by geography and the brutal exploitation of prisoners from the Dora Mittelbau concentration camp, where thousands died under inhuman conditions, building the components of a weapon they would never understand. On the military front, General Eisenhower quickly understood the strategic danger represented by the V-2. Although its accuracy was limited and its impact, from a tactical perspective, less decisive than that of a massive bombing campaign, the psychological effect was overwhelming. Cities like London and Antwerp were hit. The mere possibility that an enemy force could attack without warning and from a safe distance completely altered the defense doctrine of the time. Special operations, reconnaissance flights, bombings against supply lines, and sabotage patrols behind enemy lines were organized, but the V-2s kept falling. The Allies' obsession with understanding this technology led to a covert race even before the war ended. The entry of the Red Army into the eastern zones of Germany allowed the Soviets to capture facilities, missile remnants, and part of the technical equipment. The Americans, for their part, launched Operation Paperclip, through which they extracted von Braun and over 100 of his engineers to the United States. The decision was pragmatic and controversial. Men who had worked for the Nazi regime, even using slave labor, were integrated into the American scientific apparatus. But the benefits were strategic. Von Braun ended up leading the development of the Saturn V rocket, which took the first astronauts to the moon in 1969. For the Soviets, the partial capture of technicians and the replication of V-2 models under the direction of Sergei Korolev allowed them to boost their own space program, which would eventually place Sputnik into orbit in 1957. Thus, the V-2 became the direct link between total war in the 20th century and the space race that defined the Cold War. It was the first machine that demonstrated that outer space was attainable by human technology. The sky had ceased to be a limit. The amazement it caused among the Allies was not limited to the military field. The scientific community immediately understood the civilian potential of this technology. The equations that allowed the calculation of ballistic trajectories were the same that, a decade later, would allow satellites to be placed in orbit. The technical reports of the V-2, its guidance systems, its liquid fuel engines, everything was studied with a mix of fascination and urgency. The world had witnessed the birth of the ultimate weapon, but also of a new type of humanity, one that could leave the planet with the same violence with which it learned to destroy it. For the post-war public, the memory of the V-2 became imbued with an almost mythical aura. They had arrived without warning, like a hammer from the gods, and then disappeared to be transformed into space rockets. What the Nazis had conceived as an instrument of vengeance was recycled by the superpowers as a tool of technological conquest. But the underlying message persisted. If a dictatorship with limited resources had managed such a technological leap in such a short time, what would come next? The flying wings of Hitler, Ho 229. When the Allies stormed into Germany towards the end of World War II, they expected to find tank factories, abandoned submarine bases, encrypted documents, or conventional fighter planes. What they did not expect, and what ended up deeply astonishing the engineers, pilots, and Allied air intelligence, was to discover a project that seemed more suited to a science fiction novel than the real world. The Horten Ho 229. They found it in Gotha, at the facilities of the company Gothaer Wagenfabrik, where the brothers Reimar and Walter Horten had secretly been developing their revolutionary jet flying wing design. The impact was immediate and profound. There, before the astonished eyes of US Army technicians and British intelligence agents, lay the sleek form of a plane with no fuselage or tail, whose smooth contours and clean lines defied everything that was known about military aerodynamics at that time. Reports described the Horten as a radical leap in technological design. It was the first jet-powered flying wing, and its composite structure, partially made of laminated wood and plastic materials, had been designed with the aim of reducing its radar cross-section. It was, in essence, a prototype of what would later be known as a stealth aircraft. For the Allies, the discovery was unsettling. Had Germany managed to make more than one of these aircraft operational, the air war would have been completely different. The Ho 229 not only promised speeds approaching 1,000 kilometers per hour, faster than the British Mosquito or even the P-51 Mustang, but its design also drastically reduced its radar signature, making it almost undetectable to Allied air defense systems based on radio waves. If this plane had enough speed, perhaps it could carry bombs to New York and destroy the Big Apple with who knows what other bomb. The greatest impact, however, did not come from what the plane was, but from what it could have been. The Ho 229 V3, the third prototype found almost finished, already had the Junkers Jumo 004B1 engines installed and displayed all the necessary features to fly. Its monolithic structure with no vertical stabilizers, retractable landing gear and integrated control surfaces hinted at a new paradigm of aerial warfare. Air intelligence technicians and the personnel from the LUSTY, Luftwaffe Secret Technology, project of the US Army Air Forces, responsible for collecting and studying German military technology, classified the Ho 229 as one of the most important discoveries of the conflict. It was immediately packed and sent to the United States under the umbrella of Operation Paperclip, along with scientists, blueprints, and other items of interest. The T-Force reports detail that its recovery was prioritized over other experimental designs, which already indicates the alarm it caused upon its appearance. In British and American aviation circles, the reaction was a mixture of admiration, concern, and humility. The designs of Northrop, for example, which had experimented with flying wings in the 1930s, were suddenly overshadowed by the applied pragmatism of the Hortens. While the Americans were still testing their models with propellers, the Germans had already built a jet-powered device, almost operational and with potential stealth capabilities. The design of the Ho 229 ultimately influenced Jack Northrop's research, who, inspired by what was found in Germany, resumed his work on flying wings more intensively in the 1950s, eventually leading to developments like the B-2 Spirit decades later. It was not just the engineering that fascinated. The context in which the Ho 229 was developed also impressed. Under constant bombardment, with a scarcity of materials and a collapsing Reich, the Hortens had continued their work almost alone, under the protection of Hermann Göring, who had approved the project as part of his 1000x1000x1000 initiative, a plane capable of carrying 1,000 kilograms of bombs 1,000 kilometers away at 1,000 kilometers per hour. The Ho 229 was the only German aircraft that truly came close to fulfilling these requirements, and its design broke all conventions. Doubts soon arose. How many more were under construction? Had they been tested in combat? Did the Soviets know about these developments? The Allies began to investigate more deeply the Gotha archive, the engineers' diaries, and the Horten brothers' blueprints. They discovered that, in fact, two previous prototypes had flown, the V1 as a motorless glider and the V2 as a motorized model which crashed after a technical problem. The V3, found by the Allies, was ready for its first tests with engines, which makes its capture all the more impressive. For the Americans, the revelation had concrete consequences. The Ho 229 was sent to Wright Field in Ohio, where it was thoroughly examined. Its components, particularly its wood structure coated with special resins, revealed that an attempt had been made to absorb or deflect radar signals. There was nothing comparable in the West, and some technicians claimed that had they flown in large numbers, these aircraft could have penetrated British airspace undetected. During the Cold War, files about the Ho 229 remained partially classified. Its influence was direct on the research of stealth technologies. Although the V3 was never fully tested, and the aircraft was stored for decades at the Smithsonian Institution, Its legend grew in military and aviation circles. Declassified documents in the 2000s confirmed that the model was the subject of studies that foreshadowed the development of RAM, radar absorbent material coatings, and aerodynamic studies that would influence tailless designs. Thus, what the Allies found in a bombed hangar in Gotha was not just an experimental rarity, but a warning of what the Third Reich, even in its agony, had managed to conceive. The Ho-229 did not change the course of the war, but it changed the perception of what was possible. Its lines, so futuristic they could have come from a science fiction story, were etched into the minds of those who discovered it as the final symbol of a Germany that bet everything on technology in its final desperation. And although it never flew in squadrons, its shadow stretched for decades over the drawing boards of the victorious powers. The Volkssturm, the child soldiers of the Third Reich. When the Allied troops burst into Germany in the final months of World War II, they expected to face the exhausted remnants of the Wehrmacht, veteran soldiers weakened by years of fighting, and fragmented units still answering the Führer's call. What they did not anticipate finding in the rubble of the Reich was the silent and ghostly resistance of the Volkssturm, an improvised army of civilians, adolescents, and the elderly, armed with outdated rifles, Panzerfausts, and a determination as desperate as it was absurd. The term Volkssturm, Storm of the People, had been officially introduced by Adolf Hitler in October of 1944, when the military situation was already untenable. Under the nominal command of Martin Bormann and directly controlled by the Nazi Party, this civil militia was conceived as the last bastion of national resistance, a total effort by the people to defend the homeland against the imminent invasion. The idea was not new. During the Napoleonic Wars, Prussia had resorted to the general mobilization of the Landsturm. But in 1944, with the military apparatus exhausted and the fronts collapsing, this mobilization of civilians became a necessity, not an option. In the eyes of the Allies, the appearance of the Volkssturm was bewildering. The first signs came from the Eastern Front, when Soviet troops advancing toward Berlin began to notice that some villages were being defended by men who barely knew how to wield a weapon. Captured prisoners turned out to be 14, 15, or even 60 years old. Some wore tattered uniforms from World War I, others barely a black band with the swastika on their arm, the only insignia of their membership in the new People's Army. Initial Soviet reports thought they were irregular snipers, scattered groups, or even enemy tricks. But when they crossed the Oder and approached the cities, they understood the scope of the phenomenon. The American and British soldiers advancing from the west encountered the Volkssturm later, in places like Aachen, Essen, and the banks of the Rhine. At first, they did not believe the reports. A platoon of schoolboys ambushing a Sherman tank with Panzerfausts. Elderly men with white mustaches shooting from the rooftops with Mauser bolt-action rifles from the year 1871. But it was real. It wasn't a trick. It wasn't propaganda. It was the last and deranged expression of the total Reich, war as the duty of every man until extinction. What disturbed the Allies the most was not the tactical threat of the Volkssturm, although in some cases it caused significant casualties with its desperate attacks, but the symbolism. It was the living evidence that the Nazi state did not surrender, did not accept defeat, and was willing to drag its entire people into a suicidal spiral. Seeing a 13-year-old boy aiming a weapon at a tank, knowing he would be destroyed moments later, did not inspire fear, but a mix of bewilderment and horror. What kind of system could instill such fanatic loyalty even when everything was lost? The Volkssturm units varied greatly. Some were organized with basic training and party officers in command. Others were barely disordered bands with scant ammunition, hastily trained by World War I veterans or instructors from the Hitler Youth. It is estimated that more than 6 million men enlisted, though only a fraction ever fought. Of these, tens of thousands died without their names being recorded, in the alleys of Königsberg, in the ruins of Breslau, in the improvised trenches of Seelow, or in the suburbs of Berlin. For the Allied soldiers, the Volkssturm represented an anomaly. While the professional German armies began to surrender by the thousands, even entire divisions threw down their weapons before the Allied tanks. These civilian fighters persisted. Some British officers reported that the members of the Volkssturm did not understand that the war was lost. They had been indoctrinated until the very last moment. They believed in the Bolshevik invasion, in the international Jew, in the miracle weapons that would change the course of the war. They died with the same slogan they had lived with: Hitler is Germany and Germany is Hitler. What the Allies discovered beyond the tactical impact was the psychological X-ray of a regime that had sacrificed all rationality on the altar of fanaticism. The Volkssturm was not a military force. It was the brutal reflection of a nation dragged into self-destruction. The trenches dug by schoolchildren, the ambushes of teenagers on bicycles, the improvised cemeteries with wooden crosses stuck in the sidewalks, all spoke of a people hypnotized, educated to die rather than surrender. In subsequent interrogations, many Volkssturm prisoners showed a mix of confusion, fear, and pride. Some had been forced under threat to join, others had volunteered, some did not know how to use the weapon they carried. Others had a photo of Hitler in their pocket, carefully plasticized like a talisman. In the eyes of the American and British soldiers, this was more than a rarity, it was a warning. The Nazi ideology would not die easily. Even without an army, without airplanes, without cities, there were still those willing to resist with a stick, a grenade, or a word. The Volkssturm did not change the course of the war. It did not stop the Allied advance or significantly delay the fall of the Reich. But its existence marked a before and after in the perception of the enemy. It was no longer just about defeating an army. It was about dismantling a system that had infected every fiber of German society. For the Allies, the discovery of the Volkssturm was the definitive confirmation that the war would not end with the occupation of Berlin, but that only there would the real challenge begin, rebuilding a broken nation, educated in the cult of death. Secret tunnels. As the Allied forces penetrated deeply into the heart of the Third Reich, they began to discover facilities, laboratories, and factories that defied any previous expectations about the level of scientific and technological development reached by Nazi Germany. One of the most puzzling discoveries that generated a wave of astonishment mixed with fear and unease was the network of giant underground facilities where the Reich had placed its last hopes. The so-called Vergeltungswaffen, or retaliation weapons, which included the V1, the V2, and an ambitious array of even more secret projects. But what most impressed the Allies was not just the destructive power of these weapons, but the environment in which they had been conceived. Tunnels kilometers long carved into mountains, factories built underground, secret testing centers in forests, and complexes that seemed more appropriate for an extraterrestrial civilization than for a country on the brink of collapse. One of the most iconic sites was the Mittelwerk complex in the Harz Mountains, an underground facility built from the tunnels of Mount Könstein. It was there that V2 missiles were mass-produced under infernal conditions, using slave labor from the Dora Mittelbau concentration camp. When the American soldiers entered the tunnels, they were paralyzed by what they saw. Production chains hidden beneath tons of rock, high-precision machinery operating in the depths of the earth, railroad cars moving along underground rails, gigantic electric generators, hypergolic fuel depots, and human skeletons still chained to the walls. The contrast between the technological development of the facilities and the brutality with which the forced workers were treated was difficult to comprehend. It was as if modernity and barbarism had fused into a single structure. What most surprised the Allied engineers and intelligence officers was the degree of foresight with which everything had been projected. Those tunnels were not makeshift shelters or desperate constructions. They had been designed with a long-term vision. They had ventilation systems, drainage, hermetic chambers for explosive tests, and sections intended for the final assembly of missiles. Blueprints were found that spoke of new types of rockets, some capable of reaching America, and parts that did not resemble any known designs. The US troops even stumbled upon components of what seemed to be a suborbital rocket plane project. General Eisenhower, upon receiving the first reports, ordered the highest priority for the technology seizure operation, known as Operation Paperclip. It was no longer just about defeating the enemy. It was about absorbing their knowledge before the Soviet Union did. In the Nordhausen area, the remains of liquid-fueled rocket engines were found, engines that the Allies had never developed themselves. Near Peenemünde on the Baltic coast, the launch pads from which Werner von Braun had overseen the first tests of the V-2 were found. Everything was covered by a layer of silence and ruins, but beneath the ashes, fragments of something immense remained. The Allied reports spoke of future science in the hands of a mad regime. One British officer who entered the complex stated that the discovery was equivalent to having traveled 20 years ahead to discover what the next war would be. But it was not just the V-2 missile that captured attention. In tunnels dug in Austria, such as the B-8 Berg-Crystal complex, the Allies found the assembly lines for Me-262 jet fighters, the first operational jet-powered aircraft in history. What was most astonishing was Germany's ability to move these entire production chains underground, keeping them active and functional even when its cities were reduced to rubble. The level of automation, the ventilation systems, and the modular assembly shocked even technicians from companies like General Electric and Boeing. In other tunnels, such as those at Jonestal near Ohrdruf, cyclopean structures carved into granite were discovered, whose purpose remains a matter of debate. Some Allied researchers believed it was an underground barracks for Hitler. Others spoke of a nuclear weapons development center. In any case, what they found there, armored doors, pressurized rooms, tunnels with no visible end, was enough to fuel speculation for decades. The idea that the Reich had prepared to continue the war from the depths of the earth with revolutionary technology and beyond the reach of bombers seemed straight out of a science fiction novel. But it was real. The Soviets, upon reaching sites that had escaped the Western advance, also found similar facilities, often better preserved. They captured trains loaded with rocket components, turbines, documents, and, above all, scientists. In the weeks following the fall of Berlin, a true race began among the victorious powers to seize the technological legacy of the Reich. The Allies then understood that they were not only dismantling a defeated enemy, but inheriting a scientific revolution nurtured in the heart of a dictatorship. Every blueprint, every valve, every mathematical calculation could be the key to the next era of weaponry. The surprise was not only technical, it was philosophical. How had it been possible for a nation capable of such technological advances to have surrendered to the cult of genocide and extermination? How could a motor be developed that would take man to the moon and at the same time use chained slaves to tighten the bolts of that motor? The contrast was unbearable. Many American officers, when touring Mittelwerk or Nordhausen, spoke of a feeling of moral vertigo, a form of advanced civilization that had completely renounced its soul. Those underground factories, discovered amid smoke, corpses, and steel, marked a milestone. They were proof that the Third Reich had bet everything on science as salvation, but had contaminated it with ideology and death. And while the Nazi missiles did not change the outcome of the war, they would change the world. In space, in the arms race, in the way countries conceived defense and destruction. The Reich's tunnels thus became the dark antechamber of the future, a future that would no longer belong to Hitler, but which carried the marks of his delusion. Nazi helicopters, Fokker-Achilles Fa 223 Drach and Flettner Fell 282 Colibri. Among the jet planes, the plans for tailless fighter planes and guided missiles, there was a surprise that, though more modest in scale, left many aviation experts stunned. Germany had already built and tested fully functional helicopters. At a time when the concept of vertical flight was still a distant and experimental idea in most countries, the engineers of the Third Reich were already producing coaxial rotor aircraft capable of taking off and landing vertically, hovering without moving forward and maneuvering in tight spaces. These German helicopters were, to the eyes of the Allied technicians, a revelation. Two models stood out in particular: the Fokker-Achilles Fa 223 Drache and the Flettner Fell 282 Colibri. Both were fully operational developments that not only flew but entered limited production phases, participated in test missions, and demonstrated a technical capacity that put them decades ahead of their contemporaries. The Fa 223 was the first helicopter in the world to cross the Alps. Equipped with two large rotors mounted on either side of the central fuselage, a configuration that guaranteed stability, it was capable of carrying up to 1 ton of payload, flying at over 180 kilometers per hour, and performing transport, evacuation, or reconnaissance missions in mountainous or inaccessible areas. The Allied pilots who inspected its remains after the collapse of the Reich were amazed by the size of the aircraft and its potential. This was not an improvised prototype, but a technically advanced war vehicle designed to meet a specific need in the European theatre of operations. Even more impressive was the Flettner Fell 282 Colibri, a lightweight observation and liaison machine that was decades ahead of the concept of the reconnaissance helicopter. This small two-seater featured interlaced rotors in a synchropter configuration, a revolutionary solution to avoid the use of a tail rotor. It was designed to take off from the decks of small warships, perform naval reconnaissance, and return to the ship without the need for a landing strip. By 1944, more than 20 fully operational units had been produced, some of which flew real missions over the Adriatic or the North Sea. Its pilots described an unprecedented sense of control, versatility unimaginable in a traditional aircraft, and the ability to escape hostile areas vertically. The aircraft could reach 150 kilometers per hour, had good range, and extraordinary agility in hovering flight. The British and Americans had never developed anything so sophisticated. The sight of these functional helicopters, even equipped with closed cabins, advanced instrumentation and reinforced landing gear, shattered the notion that the helicopter was still a mere chimera. When the Allied intelligence specialists accessed the blueprints, flight records, and remains of the prototypes, the astonishment turned into urgency. The technology had to be recovered before it fell into Soviet hands. The technical teams inspecting the Flettner and Fokker-Achilles factories were sent to gather all possible documentation. The German test pilots were detained and subjected to long interrogations. In some cases, they were even offered to work for the Allies under new contracts, just as had happened with rocket scientists and aerodynamicists. The interest was not only military. The helicopter represented a new era in transportation, in medical evacuation, in logistics for rural or mountainous areas. What Germany had achieved in the midst of war, with limited resources and under constant bombing, defied any predictions. The internal reports from the United States Army Air Forces reflected this mixture of confusion and admiration. One of the technicians from the aircraft exploitation team T-Force wrote that the FL-282 was the first truly operational helicopter in the world, and that its design was so advanced that any previous Western helicopter attempt pales in comparison to its maneuverability and technical reliability. The Americans, who were just conducting tests with rudimentary models like the Sikorsky R-4, realized that Germany had already surpassed the experimental phase and entered field production. Nazi propaganda had shown some flights of the Colibri in military newsreels, presenting it as a symbol of German technical superiority. However, its existence had not received much international attention, much less within the Allied military circles. That is why its discovery after the fall of the Reich was so shocking. This was not a gigantic and destructive apparatus like the V-2, but a silent, efficient machine designed with precision, with tactical vision. It was the kind of tool that could have changed the war in scenarios like Stalingrad or the Ardennes, allowing for quick evacuations, transport of ammunition in difficult-to-reach areas, or vertical exploration in extreme conditions. After the war, the designs of the FL-282 and the FR-223 were copied, reinterpreted and absorbed by the aerospace industries of the United States, France, the United Kingdom and the Soviet Union. Some of their principles, like the use of coaxial rotors, active stability systems and reduced cockpits for tactical observation, ended up being pillars in the development of military helicopters during the Cold War. The FL-282 was even reassembled by the Americans and flown in secret tests in 1946. In retrospect, the helicopters of the Third Reich not only demonstrated the extreme level of technical advancement that Germany had reached in certain areas, but also revealed a new horizon of warfare, one in which the sky was no longer exclusive to fixed-wing aircraft, but also to machines capable of hovering like insects in the air, observing, fleeing, or rescuing. A three-dimensional war where the rotor would be as feared as the propeller. And although the Nazi helicopters did not decisively influence the final outcome of the conflict, their mere existence was enough to change the course of global military thought. What the Allies saw was not the future, it was a hidden present, too advanced to have been deployed in time. The supercannons Vi-3. Buried in the hills of Mimoyex in northern France and camouflaged under thick layers of concrete, the supercannons Vi-3 of the Third Reich represented one of Hitler's boldest and megalomaniacal gambles: to bomb London without the need for rockets, planes, or troops. This time, the city was to be hit by a rain of projectiles launched from an impossible distance, propelled not by a single shot, but by a series of controlled explosions that would accelerate their speed along a cannon over 130 meters long. It would not be a salvo, it would be a deluge. London was to be punished by dozens, hundreds of shots daily, launched from an undetectable, unreachable underground system with no possible defenses. The weapon, baptized as Hochdruckpumpe, high-pressure pump, was known to the Allies as the Vengeance Weapon 3 or simply V3. Unlike the V1, the flying bomb that hummed across the skies of southern England, and the V2, the first supersonic ballistic missile, the V3 was not an autonomous bomb, but a monumental piece of artillery. Its principle was as simple as it was brilliant. Instead of relying on a single charge of gunpowder to propel the projectile, the cannon was designed with a series of lateral chambers positioned along its barrel, firing in a precise sequence after the passage of the projectile, progressively increasing its speed. The expected result was devastating. Projectiles weighing 140 kilograms fired over 150 kilometers with a rate of one every few minutes from multiple cannons aimed at the heart of England. Construction of the Mimoyex site began in 1943 under the direction of SS General Hans Kammler, the same architect of the extermination camps and the V2. Vertical tunnels were dug into the limestone of the region, underground transport rails were set up, and more than 5,000 slave workers, mostly prisoners of war and deportees, were mobilized. The goal was to have 25 cannons ready, buried in slopes, protected by tons of concrete, hidden from Allied bombers, and capable of firing 600 times per hour. Hitler's dream was to turn this battery into an inverted version of the Hell of Verdun, a constant fire that would break the British morale and force Churchill to negotiate. London was to be subjected to an incessant pounding that would last for weeks. But the weapon had its invisible enemies. Since British intelligence had learned of its existence, the obsession with destroying the Mimoyex site became an absolute priority. In 1944, the RAF began a systematic bombing campaign, but the depth of the installation prevented effective damage. It was then that the Allies tested a revolutionary weapon, the Tall Boy, a 6-ton penetrating bomb designed by Barnes-Wallis to pierce bunkers. In July of 1944, a squadron of Lancaster bombers dropped their Tall Boys on Mimoyex. One of them penetrated the rock and exploded near the main tunnels, collapsing critical sections of the complex. It was a surgical strike. It destroyed elevators, machinery, and part of the ventilation system. The site was evacuated. Kamler, who had personally overseen the progress, ordered the suspension of the project just as the first firing tests were beginning. However, the V3 did not die completely. Some cannons were moved to Germany and adapted to bomb Allied positions during the Ardennes offensive, especially in Luxembourg. They fired from vertical mounts and had a shorter range, but the principle still worked. The US and Canadian artillery that found these remnants in 1945 could hardly believe they were German pieces. There was nothing in the Allied arsenals comparable in size or concept. What they found were cannons with multiple lateral ports, reinforced steel tubes, and projectiles designed to withstand extreme G-forces. A type of artillery that seemed to come from the future but had been conceived in the underground halls of the Reich during its final hours. The fear the Allies had of the V3 was more symbolic than practical. Although it never fired on London, the mere fact that Germany was about to build a continuous, automatic and remote bombing system, immune to fighters, elusive to radars and almost indestructible, represented a qualitative leap in modern warfare. The V3 was not just a superweapon, it was a factory of death at a distance, industrial, emotionless, without pilots, without return. A nightmare made of steel and concrete. In the interrogations after the war, some engineers from Fieseler and Rheinmetall recounted how the project had been pursued obsessively by Hitler. It was said that the Führer consulted daily on the progress of the tunnels and the ballistic calculations. He wanted the V3 to be unveiled with a bombing on his birthday, the 20th of April, 1945. But London never heard its roar. What the Allies did hear were the echoes of the project, technical documents, mathematical calculations, tubes still hot from test shots. The conception of the V3 anticipated modern electromagnetic artillery systems, railguns and hypersonic platforms that today seek to bypass missiles and return to the pure, fast, unstoppable projectile. Like so many other technologies of the Third Reich, the combination of fanaticism, urgency, and technical genius generated something that bordered on the impossible. In the end, the V3 was another of the war's sleeping monsters, a piece that never entered action by days, meters, or tons of concrete. But its shadow stretched far, like the shot that never was, and its existence remained as a warning. Time does not always reach reason, but it can reach terror. The Luftwaffe's jet aircraft. In the dark skies, a new silhouette appeared, faster than any plane ever seen before, almost ghostly in its speed. For the Allied pilots, this was a harbinger, an enemy that could no longer be caught, intercepted, or shot down using traditional methods. The era of the jet fighter had arrived, and Nazi Germany, in the midst of its collapse, had taken the first step toward the future of military aviation. The development of jet-powered aircraft marked one of the most revolutionary advances of the conflict, and their sudden appearance generated astonishment, fear, and fascination among the Allies, who still relied on the speed and power of their P-51 Mustang, Spitfire, and Tempest propeller-driven aircraft. The first to appear in combat was the Messerschmitt Me 262, the first operational jet fighter in history. Its design had begun in 1938, but its development was slow and full of obstacles, mainly due to the immaturity of jet engine technology. The Junkers Jumo 004 engine was a marvel for its time, but had a lifespan of only 25 flight hours, required scarce strategic materials, and was highly sensitive to abrupt maneuvers. Even so, once airborne, the Me 262 could fly at over 850 kilometers per hour, easily outpacing any Allied aircraft. It was armed with 4 Mk 108 30mm cannons and could carry R-4M air-to-air rockets. In combat, the Me 262 could attack and disappear before its enemies could react. It was not uncommon for a single aircraft to shoot down 3 or 4 bombers in a single pass. The Allies, initially puzzled, soon began to seriously fear the mass production of these fighters. Hitler's orders, however, partially sabotaged their success. Obsessed with strategic bombing, Hitler wanted to turn the Me 262 into a fighter bomber, delaying its entry into active service as an interceptor. By the time it entered systematic combat in 1944, the war was already lost, and only a few dozen were available with trained crews. Elite units like JV-44, commanded by Ace Adolf Galland, tried to reverse the situation, but it wasn't enough. Nevertheless, its mere appearance forced the Allies to modify tactics, flight routes, and deploy escort fighters much earlier, because the Me 262 was lethal and virtually invulnerable if not caught by surprise during takeoff or landing. But the Me 262 was not the only one. The Heinkel. His 162 Volksjäger, People's Fighter, emerged as a desperate attempt by the regime to produce a cheap fighter, easy to manufacture and operated by young members of the Hitler Youth. It was a small aircraft with a wooden fuselage and a BMW 003 engine mounted on the fuselage. It could reach 900 kilometers per hour and had acceptable maneuverability, but its danger was not in the air but on the ground. It was unstable, fragile, and its maintenance was a nightmare. Many crashed during their first flights. Despite this, the He-162 managed to shoot down Allied aircraft, and its design would be studied carefully by the victorious powers for its minimalist approach. Another attempt was the Arado R-234 Blitz, the first jet bomber in the world. Although originally conceived as a reconnaissance aircraft, it was also adapted for bombing, with a cruising speed superior to that of any Allied fighter. It flew so high and so fast that many missions were carried out without being touched. Some models used auxiliary rockets for takeoff, and one of them flew over Normandy during the invasion without the Allies being able to intercept it. The more experimental models bordered on science fiction. The Lippisch P-13A, delta-winged, powered by coal, the Bachem Bar 349 Natter, a small manned vertical fighter that took off by rocket, attacked with rockets, and then broke into sections so the pilot could descend by parachute. Although the Natter was tested with humans, one of them died in the first attempt. There were also secret projects such as the Messerschmitt P-1101, a precursor to the variable geometry fighter, or the Horten Ho 229, a stealth flying wing that was already hinting at radar invisibility concepts. For the Allies, these aircraft were not simple technological advances, they were a window into the world of tomorrow. The British and American intelligence delegations that entered the Messerschmitt, Arado and Heinkel factories in the final days of the war were stunned. In hangars half destroyed or hidden underground, they found prototypes that could have changed the course of the conflict if they had been deployed earlier and in sufficient numbers. It was not an exaggeration. A squadron of Me-262s could have wreaked havoc on a formation of bombers, and only the shortage of fuel, trained pilots, and time prevented its impact from being even greater. The United States Operation Paperclip and the secret programs of the Royal Air Force and the Soviet Union quickly incorporated this technology. The foundations for the future MiG-15, the F-86 Sabre, and many post-war jet aircraft were found in those plans rescued from the ruins of the Reich. In the end, the German jet fighters were a broken promise, a work of technical genius contained by strategic chaos and desperation. But their brief passage through the skies of Europe left a warning. The future had begun, and those who did not understand it would be left behind in the next war. The Luftwaffe's jet aircraft did not win the conflict, but they forever changed the history of aviation. The weapon of the future, the STG-44 on the battlefield, a revolutionary weapon appeared that would forever change the history of light weaponry. The Sturmgewehr 44, better known as the STG-44. This weapon was not simply a rifle nor a submachine gun, it was the world's first assault rifle, a completely new concept that left behind the classic doctrines of infantry combat. Up until that point, infantry fought mainly with bolt-action, long-range rifles like the German Karabiner 98K, or with short-range automatic submachine guns like the MP-40. Both had limitations. The rifles were slow to fire and cumbersome in close combat, while the submachine guns lacked effective range. What the STG-44 offered was an ideal middle ground: automatic or semi-automatic fire, good accuracy at medium range, a 30-round magazine, and a controllable rate of fire thanks to its intermediate cartridge 7.92 by 33 mm Kurz. It was not an improvised weapon or an experiment, but a war tool developed with tactical foresight and proven combat effectiveness. When it began to be distributed on the Eastern Front in 1944, German soldiers were fascinated. The first units received it with enthusiasm, especially assault groups and panzer grenadier units. For the first time, the German infantrymen could face the Soviet waves with a real technical advantage. Its ability to maintain sustained fire without losing accuracy or mobility gave it a notable superiority in urban combat or in forests. In fact, reports from the front indicated that a single platoon armed with STG-44s could hold off much larger forces due to the concentration of effective fire. Even Adolf Hitler himself, initially skeptical of the project, which had been developed in secret under other names such as MP-43 and MP-44 to bypass his opposition, eventually accepted mass production once he saw its effectiveness. By officially approving the name Sturmgewehr, assault rifle, he simultaneously christened a category of weapons that would dominate conflicts of the 20th century. The Soviet AK-47, the American M16, and all their subsequent derivatives owe their conceptual existence to the STG-44. Despite its exceptional performance, the STG-44 came too late and in insufficient numbers. Only about 425,000 units were produced before Germany's collapse. The bombed infrastructure, lack of raw materials, and logistical chaos prevented its mass distribution, but its impact was immediate. The Allies, upon capturing specimens, were surprised by its advanced design. British intelligence described the weapon as the greatest individual advancement in weaponry since the machine gun. In short, the STG-44 was a weapon born of urgency but ahead of its time. It did not change the outcome of the war, but it did change the way all subsequent wars would be fought. It was the first step towards the era of the modern assault rifle, and its legacy still fires in the trenches of the 21st century. The missiles and radio-controlled weapons. The German engineers, engaged in an unprecedented arms race, secretly developed a weapon that seemed straight out of science fiction: radio-controlled missiles capable of correcting their trajectory in mid-flight and striking targets with unprecedented precision. These systems, which today might seem rudimentary, were at the time an absolute revolution in technological warfare and marked the beginning of a new era, that of smart weapons. The cornerstone of this development was the Fritz X, an anti-ship guided bomb designed by Ruhrstahl. At first glance, it appeared to be a conventional bomb, but it concealed within it an aerodynamic control system that allowed the gunner from the launching aircraft to direct its fall via radio signals. The Fritz X had 4 small wings that provided stability and maneuverability, and it could penetrate up to 5 meters of naval armor thanks to its perforating design and the speed gained during its descent. The Fritz X was first used in combat in 1943 with a spectacular result. On September 9th, during the Italian surrender, a German Dornier Do-217 bomber launched a Fritz X at the battleship Roma, the flagship of the Regia Marina. The missile struck with surgical precision, pierced the armored deck, and caused a devastating explosion that split the ship in two, sinking it within minutes. More than 1,000 sailors died, including Admiral Bergamini. It was a brutal demonstration of what the new technology could achieve. Shortly after, other Fritz X bombs effectively hit the British battleship Warspite, leaving it out of action for months, and caused significant damage to the USS Savannah and the HMS Uganda. The Allied fleets, accustomed to relying on their size, speed, and anti-aircraft artillery, began to realize that no armor was sufficient against a bomb that could be guided with precision from miles above. Alongside the Fritz X, the Germans developed the HS-293, a missile more akin to an unmanned aircraft. It carried a 500-kilogram explosive warhead, wings, and a small rocket engine that propelled it after being launched from bombers like the Heinkel He-111. The operator, using an optical sight and a joystick, guided the missile toward the target by following a flare on its rear. Although less penetrating than the Fritz X, the HS-293 was effective against destroyers, transports, and cargo ships and was used extensively in the Atlantic and the Mediterranean. The introduction of these weapons left Allied command in a state of bewilderment. For the first time, an attacker could launch their payload from outside the range of anti-aircraft artillery and calmly direct it straight to a vulnerable point. This ability completely changed the nature of naval combat and forced the development of electronic countermeasures. The British responded urgently, implementing radio jamming systems like Carpet to divert the guidance signals, achieving some success. Electronic warfare was born in parallel with the missile war. However, the German guided missiles had limitations. Their use depended on visibility. The operator had to see the flare until impact. Additionally, they could be diverted by atmospheric conditions, interference, or evasive maneuvers, and above all, they required precise training and preparation time, which Germany, under constant bombardment, had less and less. Still, their psychological and strategic impact was significant. Allied pilots, sailors, and commanders knew that a single guided bomb could destroy an entire ship. The legacy of these weapons was immense. Although the Fritz X and HS-293 disappeared with the end of the Third Reich, their technical principles served as the foundation for the development of modern missiles. In the United States and the Soviet Union, teams of captured or surrendered scientists from Germany were interrogated and hired. Reports on the effectiveness of these bombs were thoroughly studied, and in the following years, weapons like the AGM-12 Bullpup, the AS-20, and eventually current cruise missiles and smart bombs were born. The electromagnetic cannon of the SS. In that climate of technical urgency and war fantasy, the interest in a weapon was born that even today represents the intersection between science fiction and the weaponry of the future, the electromagnetic cannon. This project, known in some sources as Rheinmetall EMW Gerät or simply as Kugelblitzwaffe, was based on a revolutionary principle: to dispense with chemical explosives and use intense magnetic fields to launch projectiles at hypersonic speeds. Unlike traditional cannons, which rely on the ignition of gunpowder or derivatives, electromagnetic cannons, also known as railguns or linear launchers, use the Lorentz force. This force is produced when an electric current flows through a conductor placed in a magnetic field, causing a brutal acceleration of the projectile lodged between two metal rails. In theory, this technology would allow speeds impossible for conventional artillery, generating devastating impacts without the need for explosive charges in the projectile. During the Third Reich, the theory of electromagnetism was not new, but applying it to a weapon system was. By the middle of the war, German scientists serving the Wehrmacht began to explore whether these principles could materialize into a functional prototype. The company Rheinmetall-Borsig, one of the most important in the field of artillery, was assigned to research these weapons as part of the Wunderwaffen, or miracle weapons, that were supposed to reverse the course of the war. In secret, experimental models were developed in facilities located around Hillersleben and Peenemünde, where rocket and jet engine tests were also being conducted. One of the declared objectives of this weapon was twofold: to surpass the Allied artillery in terms of range, accuracy, and rate of fire, and to develop an unstoppable weapon whose speed would be so high that no armor could resist its impact. A projectile fired by an electromagnetic cannon could, in theory, reach speeds higher than Mach 6, enough to penetrate multiple layers of steel or concrete without any explosive charge. In times when Allied bombers flew over Germany with relative impunity, an anti-aircraft electromagnetic battery promised absolute defense. However, practical implementation was plagued by technical obstacles. The currents required to propel the projectiles needed colossal generators capable of producing millions of amperes in fractions of a second. This not only implied enormous electrical consumption, but also required a robust infrastructure that could withstand the wear and tear of each shot. With each test, the materials used would melt, the rails would deform, and the sparks generated put the operators at risk. The heat induced by the energy released was so extreme that after a single shot, the entire system had to be recalibrated or outright replaced. Even so, there is evidence that a small number of functional prototypes were tested in the final months of the war. Reports from the Allies, who occupied the Hillersleben laboratories and other test sites, speak of semicircular structures, copper conductors as thick as a human wrist, and metal remnants perforated by linear impacts as if an invisible bullet had passed through them. Some American engineers marveled at the ideas the Germans had outlined: underground stations capable of firing projectiles into space, weapons that would use solar energy to recharge their capacitors, and even proposals to fire projectiles across the English Channel from Calais to London without a single plane crossing the sky. In one of the most delirious proposals, the possibility of using electromagnetic cannons to launch spy satellites into space or bomb from space with ballistic trajectories was suggested, anticipating the concept of orbital weapons decades ahead of time. Although the technology of that time made such visions impossible, the mere fact that they were seriously discussed reveals the degree of desperation and marginal genius that was taking place in Nazi laboratories in the years 1944 to 1945. The Allies, upon discovering these projects, did not hide their surprise. Although they knew of the Germans' drive for military innovation, finding traces of a weapon without gunpowder that launched projectiles using magnetism was something that bordered on the unreal. The Americans, in particular, collected all possible plans and prototypes, sending them to Fort Bliss, Texas, and to research centers like Aberdeen Proving Ground. In the following years, the concept was revisited under the umbrella of Cold War weapons development, although the true resurgence of interest in railguns only took place in the 21st century. The submarine that never was, the Type 21 Electroboot. The German Type 21 submarines, known as Electroboot, represented an unprecedented qualitative leap in the history of submarine warfare. Designed toward the end of World War II, they were not simply an improvement over previous models, but a complete break with the past. While the Type 7 and 9 U-boats were essentially submarines that operated on the surface and submerged only to evade or attack, the Type 21 was conceived from the start as a true submarine, intended to operate submerged almost permanently. Its development marked the beginning of the modern era of submarine warfare. The origin of the Type 29 can be traced back to the German High Command's recognition that the war in the Atlantic was being lost. The advances in Allied anti-submarine technologies, such as centimeter radar, active sonar, depth charges, and well-trained escort groups, had made the previous models obsolete. Karl Dönitz, the head of the Kriegsmarine and architect of Germany's submarine strategy, personally pushed for the creation of a new type of submersible that could restore initiative beneath the sea. Thus, an accelerated development program was launched that would give birth to the Type 21. This submarine incorporated a series of revolutionary innovations. Its hull, with advanced hydrodynamic design, allowed submerged speeds greater than its surface speeds, something unprecedented at the time. It could reach more than 17 knots underwater, more than double the speed of previous models, thanks to its powerful 5,000 horsepower electric motors. It was equipped with large-capacity batteries, nearly 3 times the size of those in Type 7 U-boats, allowing it to stay submerged for several days without needing to surface for recharging. It also included a fully integrated schnorkel system, which allowed the diesel engines to operate and recharge batteries while remaining at periscope depth, drastically reducing its vulnerability. In terms of offensive capabilities, the Type 21 was equipped with 6 torpedo tubes located at the bow, with a semi-automatic reloading system that allowed it to fire a full salvo of 6 torpedoes and be ready for a second salvo in less than 10 minutes, a considerable improvement over previous designs. Its passive sonar system, the GHG, Gruppenhorchgerät, and the new Balkongerät greatly enhanced its target detection capabilities, even while maintaining silence. For the first time, a submarine could detect and attack without needing to surface or expose itself. The production of the Type 21 was also a milestone in industrial terms. Instead of being built entirely in a single shipyard like previous U-boats, a modular production system was adopted. Prefabricated sections were made in various factories across the Reich and then assembled in shipyards like those in Hamburg, Bremen, and Danzig. This strategy aimed to accelerate production, although in practice it encountered logistical and quality challenges. Of the 118 Type 21 submarines launched, only a few were fully operational before the end of the war. One of the few to see action was the U-511, commanded by Captain Lieutenant Adalbert Schnee. In May of 1945, it was ordered to suspend its attack after the announcement of Germany's surrender, while it was in position to launch torpedoes against an Allied naval group near Scotland. This symbolic mission, aborted due to the terms of capitulation, served as a test of the tactical potential of the new class. The Allies' surprise at the technological discoveries of the Type 21 was profound. In the months following the war, the captured submarines were meticulously analyzed by naval technicians from the United States, Britain, and the Soviet Union. At the Bremerhaven and Wilhelmshaven shipyards, specialists were astonished by the electric design, the automation of internal systems, the quality of the steel used in the hull, and, above all, the tactical conception of a vessel designed for a permanent underwater environment. One of the Type 21 submarines was taken to the United States, where it was renamed USSN 300 and used for testing. Another ended up in the Soviet Union, where it directly influenced the development of the Whiskey class and subsequent Soviet nuclear submarines. The Type 21 also inspired the first post-war U.S. nuclear submarines, such as the USS Nautilus. The post-war period also saw the technology of the Type 21 serve as a foundation for many of the world's navies. France, Britain, and especially the Soviet Union adopted components, designs, and even technical personnel from the project. The double-hull structure, the internal compartment layout, and the submerged autonomy became design standards for subsequent generations of submarines. Moreover, the very concept of submarine warfare changed. It was no longer about short-term ambushes from a submerged position, but about a strategy of deterrence and attack from depth, sustained over time. Despite its late appearance and limited participation in real combat, the Type 21 left an indelible mark on naval history. It represented the epitome of the German technical effort to regain supremacy in the Atlantic, even in a war already lost. Its legacy was appropriated, studied, and reproduced by the victors, making the submarine that never had the chance to fight the father of all modern submarines. The Allies were not only shocked by the design's capabilities, but they also recognized in it a strategic paradigm shift, something that no other German invention had managed to achieve with such clarity until that point. And in that tacit recognition, in that desire to copy and perfect what the enemy had almost achieved in time, the Type 21 U-boat found its place not in the waters of war, but in the blueprints of history and the post-war shipyards. It was the shadow that traversed the ocean floor for decades, even though its real wake had never sailed the Atlantic in open combat. A latent threat, too advanced for its time, but whose mere existence was enough to rewrite the future of submarine warfare. The Zielgerät night vision system. During World War II, Germany not only revolutionized aviation with its jet fighters and submarine warfare with its new generation of U-boats, but also advanced decades in the domain of night combat by developing infrared vision systems. One of the most notable devices was the Zielgerät 1229, also known as Vampyr, the first portable night vision system used in combat by infantry. The concept behind the Zielgerät was extraordinarily advanced for its time. The system consisted of an infrared sight attached to a Sturmgewehr 44 assault rifle, an infrared spotlight that emitted light invisible to the human eye, and a receiver that could capture this reflected light to form a visible image in a viewer. This setup allowed the shooter to see and aim accurately in complete darkness. The heart of the Vampyr was an image intensifier tube that worked in conjunction with a 200-watt infrared emitter. This spotlight was mounted on the rifle while the night vision scope was installed on the weapon's rail. The entire system required an external power source, which the soldier had to carry on their back in the form of a large battery. The complete system was considerably heavy, making it ideal only for defensive positions or ambushes, not for rapid attacks or prolonged movements. The Zielgerät 1229 began to be distributed in 1944, primarily among elite Waffen-SS units and troops assigned to combat night paratrooper raids or sabotage missions. Post-war Allied reports indicated that several German soldiers had used these devices during defensive actions in East Prussia and the forests of the Western Front, especially in key locations during the Battle of the Hürtgen Forest and in some nighttime clashes on the Oder. But Germany did not stop there. Larger and more powerful versions were also developed to be mounted on armored vehicles, such as the Panther Ausf, G-tank equipped with the Sperber Owl system. This variant included a 600-watt infrared spotlight mounted on the turret and a night sight associated with the main gun. In combination with command tanks or semi-tracked transports like the SD KKFZ, 251/20 Uhu, Owl in German, which carried 2 kilowatt infrared headlights to illuminate large sectors of the battlefield, complete mechanized night combat doctrines were tested. The idea was simple but visionary: to illuminate the enemy with infrared without being seen and attack with precision while Allied troops were still disoriented in the darkness. However, these developments came too late and in too small numbers to alter the course of the war. It is estimated that only between 300 and 310 Zielgerät, 1,229 systems, were manufactured, along with a similar number of vehicles with Sperber equipment. Additionally, the fragility of the equipment, the need for heavy batteries, and the complexity of field maintenance limited its effective use. Despite this, the Allies were surprised to discover these devices in depots and laboratories after the German surrender. The German infrared vision system of World War II was a technical breakthrough that decisively influenced the development of modern night vision devices during the Cold War. Both the United States and the Soviet Union incorporated the German lessons into their own programs, even using captured specimens for reverse engineering.